here we're going to take a look at just a full introduction to sets. So first of all, we need to know what a set is. So a set is essentially a collection. We like to call it a collection of objects, but essentially you have specified elements or members in your set. Those elements or members could be anything from numbers to dates to colors to animals, months, you name it, it can be an element of a set. We use special symbols and notations in order to denote our set. So first of all, a capital letter is going to be your indicator that you have a set, whereas lowercase letters are going to indicate that you have an element. We also have a couple of symbols that we use. So this funny looking E means element of. If you draw that funny looking E with a line through it, then U means not an element. Okay. Now when we're working with sets, we have a method called the roster method, and the roster method is a way that we can describe a set simply by listing the elements of the set. Now when we create our set, it's very important that we set it up the right way. So we're going to use what's called braces. These are the squiggly lines in order to embrace or wrap around the elements of your set. Okay, so let's say I want A, notice it's a capital, and I want it to be the set of all months that begin with the letter J. So in order to write a set, you would start by saying, okay, so my capital A, open your brace with a squiggly line, and then you're going to write in your months. Well, we know that we have January, we've got June, and July. Then you need to close with another brace or a squiggly line. Okay. Now another way is we could be given what's called set builder notation, and we're going to learn more about that here a little bit later. So again, see, I've got a capital, so this is going to be right here, this is going to be the name of your set, so we're calling it A. Now the way that this works is we have a few elements here. So what we're saying is this X is going to be the element representative, and then we've got your direction. So we have that X is an odd number, so this right here, odd number, and then between 20 and 30, this is going to be your how to find the elements. Okay, and that's what set builder notation does. It teaches you or shows you the directions for being able to build your set. So we have to go ahead and start. So first of all, we know our set is going to be A, and then we have to open it with the squiggly line. And I want odd numbers between 20 and 30. So this would be the numbers 21, 23, 25, 27, and 29. And only those elements. And there you go. You've built yourself another set. Alright, so speaking of set builder notation, so here we go specifically at what's happening. Again, we use set builder notation to describe the set, especially if you want your elements to share specific properties. And then we have a bunch of symbols. Okay, so we've got these, I like to call them the funny looking letters, but they're the double letters. So we have a double R, double N, double Z, and a double W. The double R means all real numbers. So the definition of that would be any positive or negative number. Double N means natural numbers. So those would be positive whole numbers only. Double Z means the set of integers. So when we're talking about an integer, we mean no fractions, no decimals. And then we have the double W, which is the set of whole numbers. Whole numbers are considered positive numbers, but in this case we include 0. Now, to write your notation, again, you need to write it in this form, where we have our squiggly line. You've got your letter, which is your element. The straight line tells you, or it says such that. And then it tells what letter is an element of and gives your special qualifications. So let's look at how to actually take something and write a set builder notation. So we have let H be the set of natural numbers less than or equal to 50. So here H is going to be my set, so capital H. And then we have the set of natural numbers. Okay, so we're going to go ahead, we need to choose, say, a variable to represent your elements. Now there's 26 letters in the alphabet, so you could be creative. I'm going to go ahead and use X. So we're going to identify the letter. So X is my element. Put in your straight bar, which says such that the following happens. We know that X has to be included in the set of natural numbers. So double N. And X has to be less than or equal to 50. And since all we're doing is looking for the set builder notation, we don't have to do anything else from there. Let's try another one. Let U be the set of all states in the United States of America, and J be the set of all states that border an ocean. So U would be like my universal set because we're looking at all states, but J is the set that I care about. J is the set of all states that border an ocean. So here we need to set it up. So we have chosen, let's say, X, such that the following happens. X must be contained in U. So X must be contained in the set of all states. And X borders the ocean. And then close it with your squiggly line. Now with this, we have what's called subsets. Subsets are elements in one set that are also in another. So if I have that if A and B are sets, B is a subset of A if every element of B is also an element of A. So when we do that, we write this as B. We put this squished up C with a line underneath it, and then A. Now, one thing to note is that when we have the empty set, that's always going to be a subset of any set. Now, we can use a thing called Venn diagrams in order to take a look at subsets. So we have that U is the following: X such that X is a student at Savannah Technical College. So here you would draw your universal, which is going to be a big old box. And you're going to put a U in the upper corner. So this big old box represents all students at, say, Savannah Technical College. Now the next one says that M is a Savannah Tech student taking a math course. So you need to draw yourself a circle. and label it with M, because within, say, all of the students at Savannah Tech, not every student is going to take a math course. Now the last one says is V is a Savannah Tech student taking specifically Math 1103. So that would be another circle inside your math course and label it V, because not every student taking math courses will be taking the specific course 1103. Okay, so that's just one example of subsets. A thing called a proper subset is where all elements of one set are in another, but the other set, or that second set, has at least one more element. So in other words, what we're saying is that when B is a subset of A, but A contains at least one element that is not contained in B, then B is said to be a proper subset. So we say B, draw that little squished C, A. Now again, the empty set can be a proper subset of any set as well. So just to keep that in mind when we're dealing with sets. So here we go. For example, let's say A was the set 1, 2, 3, 4, 5, 6, and B is the set 2, 4, 6. The first thing asked is B a proper subset of A? So remember, the definition is that B is a proper subset if there's at least one more element in the second set. So B has 2, 4, 6. Subset, or set A, has 1, 2, 3, 4, 5, 6. Notice B is contained here inside A, so we would say yes. Now the other question wants to know if it is just a subset of A. And again, because B is contained inside A, the answer here would be yes. And the reason for that is because every element of B is contained inside the elements of A.